Hello, my name is Simon Gustafsson. I'm the CTO of Atlantic Quantum, a company building scalable quantum computers. Now, quantum computers is a new type of computer that can solve certain problems that cannot be solved at all on conventional supercomputers. And one example comes from the pharma industry. Today, in drug development, there has to be large trials, experimental trials, to make sure the drugs work properly. In the future, with a quantum computer, we can actually simulate this process directly and saving a lot of money and time. Another example comes from communication. Today's most commonly used cryptography protocol is actually not secure. It can be hacked by a quantum computer. Unfortunately, quantum computing also has the solution to this. There's ultra-secure protocols we can implement once we have computers up and running. Also, today's supercomputers typically use a lot of energy to try to optimize things like route planning and logistics. And this task can be much more efficiently solved on a quantum computer, leading to much more efficient use of resources. Now, this is all great and will lead to a big revolution in computing down the line. But to get there, we first have to build the computer. And there are two problems related to building computers today. One is that the error rate or the performance of today's quantum bits or qubits is just not good enough. The second issue relates to the control of these qubits. The picture you see here on the lower left is a picture, not a picture from a Frankenstein horror movie, but from Google's latest quantum processor, which has these racks of server electronics and cables, and still only contains 53 qubits. It's not possible to scale this to the 100,000 of qubits you need to perform scalable and meaningful operations. This graph here can summarize the state of the field today. We're going to be in the upper right corner. We have many qubits with very, very high performance. Unfortunately, we are in the opposite corner today with hardware with very few qubits and very, very bad error rates. Now, our competitors are taking a very brute force scaling approach. They are just adding more qubits to the system without making them better, which leads to this, again, uncontrollable scaling issue as showed before. In our company, we're taking a very radical approach. We are using a different technology, which uses a different architecture, which will enable us to both make better qubits and also solve the scalability issue. So you can go up in this graph and then go to the right and reach meaningful applications much earlier. With our team, we are an MIT spin-off. We have been working in this field for a long time. We are from one of the most premier quantum science groups in the world. We have decades of experience. Our team covers essentially all different aspects of the quantum computing stack, ranging from chip design and fabrication all the way to quantum gates and to algorithms at the top. And with this team and our core IP, we have a very good shot of building truly scalable quantum computers. Thanks so much. If you want to learn more, please come to me after this talk and I can tell you how quantum will share the board. Thanks so much.